Well, hello, good people, and welcome to Lesson 42, Angle Measures and Segment Lengths. Let's go ahead and look at some more cool theorems that relate to circles. So today we're going to use these theorems to find missing angle measures and missing segment lengths, so pay close attention as we explore this stuff. So what's cool is if you are finding an angle measure, for example, if you have two lines that crisscross the circle and you want to find the measure of angle 1 here, you know that if you add the two arcs formed by the two lines and then take half of it, you get the angle measure. So, for example, if I said that this side was 62 and this side was 34, if I wanted to find the measure of angle 1, I would take 1/2. Remember, taking half of something is the same as dividing it by 2. So I'll take 1/2 of 62 plus 34. So let's see how this works out. So 62 and 34 is 96, and 96 divided by 2 is, well, that's 48. So the measure of angle 1 would be 48 in this example. Notice, if the angle is on the inside of the circle, you add. Now check this out. If you want to find, if you have two lines that intersect outside the circle, out here, then you subtract the two arcs. And you're always going to do, X is always going to be the larger arc, subtracted from the smaller arc. So it's the two arcs that are involved in creating the angle, right? So let's say if this is now 62 and this one's 34, then I would do 62 minus 34 and take half of that, right? And I'll work it out over here. So 62 minus 34, that's 12, 11, 10, 9, 8, 8, 28, and 28 divided by 2 is 14. So that would be an angle measure of 14 right here. 14 degrees. All right, and you can see that there's several different ways that these will look. You could have two tangent lines, you could have a tangent and a secant line, so on and so forth. And this is the formula used. So again, if the angle is outside, you subtract. If the angle is inside, you add. So this is to find missing angles. So a new vocabulary word is secant. So a secant is a line that intersects a circle at 2 points. So for example, it intersects a circle here and here. If it were to stop on the circle, we would call that a chord. But a secant intersects at 2. So we've learned a lot of different lines that intersect circles. So I want you to use this opportunity to draw a picture. You can use the back of your paper or a separate sheet of paper to do this because I know you don't really have space. So the first thing, a chord is going to be a line that has two endpoints. It's a line segment that has two endpoints on a circle. So this is a chord. Okay. A tangent, remember, is a line that intersects a circle at 1 point, so we call this tangent. And then a secant now is basically a chord that extends in both directions. Like this is what we call a secant. So you can see the difference between the three different kinds of line. Next, you need to know the difference between a radius and a diameter. So if you have the center of the circle, and you have a line that cuts the circle in half, we call that the diameter. And if you have half of the diameter, that's what we call the radius. So the radius equals 1/2 the diameter, and the diameter equals 2 times the radius. Okay, so now let's find angle measures, and let's practice when we see kind of different types of problems. So once again, for this one, you'll see that the angle is inside the circle. So this is going to be 46 plus 90 times 1/2. Okay? So 46 plus 90 is 136. So this is 136 divided by 2. Because remember, taking half is the same as dividing by 2. And you get 68 degrees. Now if we notice, this here is outside the circle, so it's going to be a subtraction problem. However, we're looking for an arc measure, so let's remember that when we're writing our equation. So we know that 20, which is our angle measure, is going to equal 1/2 95 minus z. And we don't know what z is. Okay, so one thing you can do to get rid of 1/2 is you can multiply both sides by 2. So if I multiply this side by 2, 2 times 1/2 is 1, so it cancels out. But because it's an equation, I have to do the other side by 2 as well. So that would mean 40 equals 95 minus, and this is a z. All right, so the next step is going to be to subtract 95 from both sides. So I'm going to bring it over here, and that gives me negative 55 equals negative z. Well, I can change these to positives, so that means that my arc measure is 55. All right, you're going to want to pause the video, and on a separate sheet of paper, you're going to want to use the information you have here to figure out what the value is, either the arc or the angle. Just remember that since the angle is on the outside, this is going to be a subtraction. This is going to be a subtraction, and this angle is on the inside, so this is addition. So pause, work it out, and then come on back and check to see that you know what's going on at this point. Here are the answers you should have gotten. For problem number 1, I just wanted you to notice that if this part of the arc is 110, then the rest of the arc is actually going to add up to 360. So there is a shortcut. You didn't actually have to use the whole formula. You could have just taken 360 minus 110. But if you did use the formula, this is what it looked like. This is one where you have to multiply both sides by 2 to cancel this 1/2 out. And then you just do the simple one-step equation. You should do that. Okay, let's look at a real-world example. So if you are finding arc measures, this is a satellite. This is kind of like how a satellite works. It's orbiting above the equator, and it creates 2 tangent lines that form a 17.5 degree angle with the Earth, okay? And so what are we trying to find is the arc measure of AB. Now, if we're given the angle measure, here would be our arc, and we'll just call this x. And then this AEB, this big arc here, we would call 360 minus x, right? And so when you're setting up your equation, it's going to be the same thing, but it's going to equal 1/2 this big arc minus the little arc, okay? And the big arc is 360 minus x minus another x. So that's where the 360 minus 2x comes from. Then you take half of 360, which is 180, half of 2x, which is x, or you could multiply 17.5 times 2, either or, right? Then you're going to subtract 17.5 minus 180, and you get 16.2. Okay. So I just wanted to show you that if they just give you the angle measure, you can still find the other arc measures. And I believe this is like number 4 in your homework. All right, now we're going to start looking at a theorem when you're trying to find side lengths. And basically your side lengths are going to be proportional when you have chords, secants, and tangents. And this is kind of like the diagram that will help you out. So if you have a situation where it looks like an X within a circle, the ratio is that if you multiply these side lengths together, it equals these 2 side lengths multiplied together. Case 2, if your picture looks like this one's a little bit more confusing, but it's basically saying that WX, if you add them, and then multiply it by the portion that's outside the circle, it equals these two added together times the portion that's outside the circle. And the same situation here, except t doesn't have any portion inside the circle. So you're just multiplying t times itself, which gets t squared. And then here you're going to do z plus y times the outside of the circle. And this will make more sense when we put some numbers in there. So that's what we're going to do next. So let's look at these cases. So in case A, we'll notice that is going to be a situation where we add and then multiply by the portion that's outside the number. So that's where we get 6 plus 8 multiplied by 6, 7 plus y multiplied by 7. So you can add this, 6 plus 8 is 14, 14 times 6 is 84, and here you have to use the distributive property, and that's where you get 7 times 7, which is 49, 7 times y, which is 7y. Okay, and that's subtract 49, 35 comes in there, and then you got 7y, divide by 7, and that's where the 5 comes in. For case B, you should notice that all we have is an outside, so that's where the z squared plays in. And here you're going to add and multiply by what's on the outside. And now here you have z squared equals 192. When you work this out, you get 192. So to get 13.9 again, whenever you have the square, you take the square root, and that's what you get. So go ahead and pause your video and see if you can work out A and B, and then come back and see if you got the correct answer. The problems worked out. So the hardest thing is to be able to look at the picture and match it up with the correct formula. So while you're doing your practice problems, you might want to pause the video on this portion so that you can see the different practice problems. All right, so at this time I was going to go through some problems with you. I'm going to again pause the video here, and you can go ahead and see if you can find x and y in these illustrations. The answers to numbers 1, 2, and 3. Let's go ahead and move forward. These problems are worked out at on your paper, but I just want to make sure that I showed you how this is done. So if I want to find this degree, remember this is going to be a subtraction problem, but before I can even work it out, I have to figure out this big arc right here, which is 360 minus 112. And that's 248. Okay, and so then I can find this measure by saying the measure of Q equals 1/2 248 minus 112. And then when you work it out, you get 68 degrees. And then over here is the same situation. The first thing I have to do is find this big loop here, 360 minus 115. And then work backwards from there, and the answer is going to be the measure of C is going to equal 1/2 245 minus 115. Okay? Please note these problems right here, this is what we've been doing. This is just an inscribed angle. So, you know, if this is 77, this part right here is 77 times 2. Which is 154, and then this part back here is going to be 360 minus 154, which is 206. So you're going to do this problem the same. This problem is an outside, so you're going to take the two angles, half of 149 minus 49, and that's where you get the measure of K equaling 50 degrees. This one's an addition problem, so you should notice because the angle's on the inside, you're going to add. So 118 is equal to 1/2 of 60 plus, I'll just say x, right? So we can undo taking half by multiplying this side by 2. So 236 equals 60 plus x, so then you subtract 60. 6 from 13 is 7, 176.